So this assignment is about the simple harmonic motion. And we did the first two questions. So question 3 today. Question 1 we did, question 2 today. I guess, yeah, last I did was question 1. Question 2. So in this question, the water level in a harbor vary with a simple harmonic motion. Explain what is meant by a simple harmonic motion. What is the meaning or a definition of a simple harmonic motion? In a simple harmonic motion, the acceleration and displacement are directly proportional. So you will write the acceleration is proportional to or directly proportional to displacement. So acceleration and displacement are directly proportional. And what else? What is the second point for this? The direction, like the object is always directed or like their acceleration is always acted towards the mean position, or acceleration and displacement are in opposite direction. Like if we have a maximum displacement, we have a minimum acceleration. We have at the mean position, like if opposite, basically the directions are opposite, but at the max, if they're directly proportional, if the displacement is more, the acceleration will be higher. Like if an object is vibrating at its extreme position, because there's more displacement, so at this position, acceleration will be maximum. But the direction of acceleration and direction of displacement are always opposite. But the motion is always directed towards the mean position. That's why when we plot a graph between acceleration and displacement, so if it is acceleration will be positive, displacement negative. If acceleration negative, displacement will be positive. So this will be the graph. So in a simple harmonic motion, the acceleration and displacement are directly proportional and always opposite direction to each other. The graph shows the variation of a water level in a harbor on a particular day. Determine the amplitude and the time period of a variation. So how we determine the amplitude? Amplitude is like, first we have to take a mean position, identify the mean position. So this is about like between, so we, how many boxes? 1, 2, 3, 4, 5, 6, and 7 boxes are there. So this mean position will be 3.5, around 3.5. So this is one box, two box, three, and about 3.5. So this will be about the mean position. Because amplitude is a distance from mean position to extreme. The number of the boxes above and below should be same. So this was about the mean position. Because we need about 3.5, and here also 1, 2, and 3, and then about, if I just raise this line up, so it's not exact because we don't have the exact marking between like 5 to 6. So if it is starting like this was say 5.25, if I consider, and this one is rising to 9, so distance from 5.25 to 9. Is it clear, this one? The amplitude might be, it can be any value, like just we take a difference between the two. So it will be 9 minus 5.25, which is 3.75. So this distance, the amplitude is coming out 3.75, and the unit is in meter. The next part is about time period. So how to work out a time period? This is in like 6 hour, 12 hour, 18 hour, and 24 hours a day. So time period is a distance, like time taken by one vibration. So you can take one crest, one trough, or you can take the time interval between the two successive crests or troughs. So you can take this value, like this is 1800, like 6 hour, then 12 hours. So from here till here, it's about 12 hours. And this value, because this will be 300 hours, so it's about like a quarter of it. So I can say like 12.25 or 12 point, this will be 300, then 400 hours, then 500. This will be because in between them, so 400, 500, 4,000, sorry, 450 hours. Then this will be 500 hours somewhat. So if I take a difference, here I will have 12 hour and then it's about zero point 0.5, 0.25 in that range. Or I can also take like this one. So either you can take the between the two troughs, you can take between the two crests, even like here, this value. So this is at 24 hours, this one is at 12. So 12 hours are there, and this also there in between. So it's like between, because this will be zero point 0.5, about zero point 0.5, so I can say 12.5. Because 11, 12, so this will be, the difference is there. 6, so this will be 300. This will be 900, 1200, 1500, 2100, and then 22, means like 24 hours is there. So in between them, this will look like 900, 1000, 1100. So it is between like say 1100, and this is 2400. When I take a difference, it will be about 1300 or 12.5, we can say. So estimation is there, as the graph labels are not exact. So time period, we work out the amplitude and the time period. The amplitude was 3.75 meter and the time period is 12.5 hours. Show that the maximum rate of change of water level in the harbor is about 2 meter per hour. So rate of change of water level means here we need a velocity. So how to work out the maximum velocity? How to work out the maximum velocity, that we have the formula V is equals to R omega, or omega A, where A is the amplitude and omega is the angular frequency. And how we can work out the angular frequency? 2 pi over T multiplied by. So this will be 2 pi 3.14 time period, because we need an hour like meter. So we don't have to convert the unit. We have the time period from the previous. 12.5 was there. And the amplitude which we worked out in meter, that was 3.75. So when we multiply, we get the maximum speed, which is about 1.86 meter per hour. We don't have to convert the unit, as the final answer we need in meter per hour. The next, add a curve to a diagram to show rate of change of water level in a harbor over a, so rate of change of water level means we want to make a velocity time graph. You use the middle of the grid as your time axis, no vertical axis required. So first, because this is a displacement time graph, first you have to identify when, like it was starting with a maximum. So means the displacement time graph is a cosine graph. So what is the derivative of cosine? When you take a derivative of cosine is minus sign. So the velocity should be minus sign, because the first is a displacement time graph, which is a function of cosine. So derivative of the velocity, derivative of the cosine is minus sign. The derivative of sine is cosine and cosine is minus sign. So means the velocity should be minus sign. What does it mean? Minus sign? Minus sign means like it will start with 0, but then move to negative axis. So sine graph will be there. And the time period should be same, like about 12.5 hours. So we take the middle of this. It's about like 4.5 as the mean position, because they mentioned 0 to 9 is there. So the center, this will be 4.5. And this will be a sine graph. So minus sine graph. So it will start with 0 but negative. And then the time period should be same, like in a same 12 hours. We should complete. Amplitude, it's not necessary it should be same, because we don't know the amplitude. Like amplitude of velocity is known, but we don't have to label the axis. That's why. But the idea is that you should be able to draw a minus sine graph, as the derivative of cosine is minus sine. So we work out displacement. Displacement was a function of cosine. That's why the velocity is a function of minus sine. And if there was an acceleration graph, then derivative of sine is cosine. So it will be minus cosine graph. So if they ask the same question, like sketch on the grid the acceleration time graph, so it should be start with like both are actually mirror images of each other. If a if this was cosine, this will be minus cosine, means it will start with a negative value and then it will continue. The acceleration graph will be like this, opposite of the will. So this was representing acceleration, blue one is representing velocity. So this was question 2 from the simple harmonic.